So, hello everyone, I'm Tom Coles. It's unfortunately pronounced Coles, not Cools. My wife has stories about that, but let's not get into that too much. I work for a company that's called InfoSupport. We have an office here in Veenendaal, so a few kilometers away. But as you can tell, I'm not Dutch, I'm from Belgium, so I work from the InfoSupport Belgian office. Next to that, as the winner of the Bad Timing Awards, my wife and I founded the Antwerp Java user group in, I believe, April 2020, which was probably the best time ever to start a user group. But I'd say you're all invited. Just check with your car insurance if it covers the Belgian roads, because I know how terrible it is. I have to drive back after this conference as well. So very much aware, but be welcome. So I don't want to talk to you today about the differences between Belgians and the Dutch people. Let's not get into that problem. Maybe at the drink we can get into that. But I want to talk about this. This is a toolbox. And for me, it's really the representation of all the things that you know, frameworks, languages, and so on. And these are the things you will grab back to whenever you have to solve a problem on your project. Because if you don't know about a certain framework or a certain way to solve something, then you're never going to use it. So it's really up to us to keep this up to date, this toolbox. Because something that was a hype today could be like a standard tomorrow. So let me take you back in time. I don't have the awesome Huey Lewis Back to the Future song, but let me take you back in time. And let's see how quickly this thing becomes creepy. So I'm going to go back in time to the different release dates of important frameworks and languages. So Java 17, pretty recent, right? Everyone's still like, yeah, okay, I remember a time before that, that's fine. So let's go back, Quarkus, a bit more recent. Then it becomes creepy, because only 5 years ago there was no Kotlin. And if you look now at our industry, Kotlin is, well, there's multiple talks on Kotlin today. JetBrains decided, well, Kotlin is going to be the language that we are going to create. And the Google team has actually decided that it's one of the primary languages to code for an Android device now. That's only 5 years ago. Kubernetes was 6 years ago. The great thing is now that, because these frameworks have released a while ago, you can really see the hype cycle. Like, it was, oh, Kubernetes, all the things, Kubernetes, all the things. And now we're like in maybe the valley of despair of all the failed projects we've had with Kubernetes so far. And then the one that really got me was Spring Boot. That thing's only 7 years old. I'm now working at InfoSupport for 8 years, so that's creepy. If you think about it, if we don't keep our knowledge up to date, something that was a hype at those points in time, the things that were just released, well, maybe things that we see today will become standard practices. And one more that was actually Docker. Can you even imagine deploying without Docker now? That's just creepy stuff. So we need to keep our knowledge up to date. And one of the concepts that I like to use to explain it is a half-life. So I'm not talking about the game, even though I use the background of the game, obviously. But a half-life is the time it takes for some value to reduce to half its initial value. So that sounds pretty complex and is usually used in like nuclear accidents. How long will it take before we can go into Chernobyl again, for example? But there's also a half-life on your knowledge. And that's the time it takes before half of what you know is actually no longer relevant anymore. Does anyone want to wager a guess how long it takes before half of your knowledge is no longer relevant? I see there up there? 15 years. And I hear people sighing, so people disagree. So anyone with a different number? 2 years. 2 years. Anyone else? 5. All right, so actually it's between 2 to 5 years. So that's 2 good answers, actually. So we have the range. It's quite creepy when you think about it, that in 2 to 5 years, half of what you know becomes kind of irrelevant. So we really need to keep our stuff up to date. And I really see a lot of people struggling with keeping up to date with all the things, because if you look at what comes at us, if you look at a day like this, all the new things you learn today, well, that's a lot. So I actually thought I would guide you through a couple of things in this session. So first I want to talk to you about what are some of the right things to learn about. Because as we say, half of your knowledge will be gone in 2 to 5 years, or will become irrelevant. then what are the good things that we could be studying or looking into? And often the internet and our sector feels a little bit like this. There's a lot of stuff. It's like, I've recently become a fan of physical books. So when you walk into a bookstore, it's kind of crazy. There's a ton of books. And that's, for me, how sometimes the IT sector feels. There's so much different things that are coming at us, and which book am I going to choose? Which framework am I going to learn? What am I going to focus on? And now, I don't know how you are in bookstores, but usually I just pick a book, look at the back, and say, oh, yeah, this is kind of interesting, and I put it back. Or I take it home. So this is different for everyone. Everyone has different preferences. Everyone has a different background. So I can't choose for you and say, you should learn this, because that just doesn't work. What I can do is give you some guidelines on what should you look into when you take the back of the cover of that book. Like, what are the things that you can focus on to get more out of your learning? And maybe I should preface this that before I studied IT, I actually got a teacher's degree, but I felt way too young to stand in front of a classroom for the rest of my life. But a lot of the lessons that I learned during my teacher's degree, well, a few of them I think are really relevant for learners as a whole. So I want to share a few of those with you. And the first one I want to share with you is the zone of proximal development. This is actually a really simple system. You have an inner circle, that's what you know at the moment. So that's all the tools, frameworks, basically everything that's really in your long-term memory at the moment. Then you have a few things that you can learn. So that's slightly away from the knowledge that you have now, but not too far. And then you have the things that are actually at the moment impossible for you to learn. And I have a practical example to maybe help you through this. So if you know HTML styling, so you know HTML tags and you know how to put a style on it, well, if you know a bit about HTML and HTML styling, then it's reasonable to assume that you'll be able to understand what a CSS file does, or how CSS works. Well, what might be too far away from you at the moment is CSS animations. Now, I'm a big fan of, what's her name again? Sarah Dresner, I believe. She makes like these crazy CSS animations and SVG animations. But it takes a while to get there. So what I really want you to take away from this is that whenever you take a subject that you want to learn or want to explore, well, basically you take a book out of the bookstore and you look at the cover. Really try to see what are the prerequisites, and not the technical prerequisites, but like the knowledge prerequisites. Sometimes this is difficult to do, but it will allow you to eliminate a lot of stuff. So, for example, I really wanted to learn machine learning, and I tried to start at it, but it just didn't work out, because machine learning is, for me, is mostly, and then my clicker doesn't work. Oh, magical, doesn't work at all. Okay, maybe like this, no? Okay, it doesn't matter. Machine learning for me is mostly in the outer circle. And I didn't really have a clear view on what are the steps that I need to take to actually get the machine learning part. So this actually helped me, this model, and just thinking about, okay, what are the steps that I need to take to learn that thing, actually helped me to choose what I want to learn or what path I should be taking. And now that's difficult when you're a junior programmer and you don't really know what steps am I supposed to follow. So there's actually roadmap.sh. So that doesn't make sense if you can't see it, of course. So there's this website that actually has different roadmaps that can help you discover, like, if I know a certain thing, what are the next steps that I can take to become a better developer? For example, let me take the Angular one, because that's a bit further away. And it actually lists like the different subtopics and in what order you could be studying these to make a bit more sense. So when you go to a university or a college, een hogeschool in Dutch, then your teachers make these kind of roadmaps for you. But now that you've graduated and you have to do lifelong learning for the rest of your life, you really need to take into account, how am I going to do this thing? Let me just close this up again. So this is a really simple model, and it has everything to do with cognitive load. Who of you knows a bit about cognitive load? Quite a few people? Okay, for those who don't know, that's not a real big deal. I actually have a hidden slide for this one, so let me just pick it up. Okay, that's freaking out completely. I gotta love IT. All right, let's talk a bit about cognitive load. So, let's see. Cognitive load actually is an idea about how your brain works. So, your working memory, so that's the things that you can have, like, let's say your RAM, to say it in computer terms, your random access memory. Well, you only have 7 slots. That's not a lot. You can only have inside your head 7 different things. And cognitive load actually applies when you're trying to study something. And there's 2 kinds of load, really. You have intrinsic load. And intrinsic load is the load, the effort your brain has to do when you don't have enough prerequisite knowledge. So when you're trying to learn Angular but you don't know TypeScript, that's a lot of intrinsic load for you. Because you're looking at Angular and you see TypeScript, but that's also weird for you. So your brain is already overloading with all the new stuff that you need to learn. Next to that, there's extraneous load, and that's extra load that appears when there's really confusing arguments and confusing instructions. For example, if you ever been to a PowerPoint presentation where all the slides have a different animation and it spins and it dances and and it looks really crazy, that's actually extraneous load. That's load that is not part of the problem, but because of the way it's presented, that's just filling up extra spots because it's confusing and it happens all over. Now, the good thing is, as you learn more ideas, more concepts, more schemas is the official term, end up in your long-term memory. And your long-term memory, actually, these schemas only take up 1 of those 7 spots. So this is why those circles make a bit more sense, because the more you know, the more schemas you actually have, and the less of your working memory you're actually occupying. So the concept of I know Java and all the things that Java entails will only take up a few of those 7 slots, not all of them. Well, if you are new to Java and you see Java code, you're basically almost immediately overloading with all the things that Java is. Because if you think about it, a class, a constructor, a method, variables, there's so much in a language. So the more you know, the easier it is for your brain. And that's why those circles make a lot of sense. So whenever you learn something, keep it into account. The second thing is that the technical implementations fade way faster than the concepts they're based on. So what does this basically mean? When you learn a new framework like Angular, that's cool. You can build cool stuff with it. But is Angular really what you should be focusing on? Or is it the concepts that Angular uses to build itself, like a controller, directives? There's concepts inside these things, and those don't fade as fast. If you think about classic, classic sounds a bit bad, but if you think about JAX-RS, so the Java EE, with all those annotations, when you think about it, they're not that different from the Spring annotations. So you can really use a lot of that knowledge. And things like clean code and design patterns actually help you a lot when you read code. Because when you see a really complex piece of code, but it's labeled with decorator, then you know, oh, it's probably a decorator design pattern. And it lowers the amount of effort you need to do to understand code. If a class is called a singleton, then yeah, you understand a bit better what that means. Clean code also helps your brain a lot, because if the code is better to read, easier to read, then the load on your brain is also way lower. So these kind of concepts if you know them, they will last way longer than any kind of programming language or whatever. Because if you started in Java and you are really good at the object-oriented part and the functional programming part, then Kotlin actually makes a lot of sense as well. Syntax is a bit different, but the concepts that you learned are still there. So when you try to study something, keep these two things in mind. Beware of your cognitive load. So when you try to study something and you notice, oh, it's just not registering, maybe you're just taking a step too far. Maybe you're just trying to learn something that you don't have the right schemas for yet in your long-term memory. So then take a step back and see which steps do I need to take to learn the next part. I remember that concepts like object-oriented programming and getting really good at it, design patterns, are things that will come back in many different programming languages. Now, if you think, yeah, but I still can't really judge if my knowledge is enough to learn the next thing, well, one thing that helped me a lot was getting a coach. Getting someone who's really expert in a certain domain and asking them just like, hey, I want to learn more about the details of Maven. Where do I start? Show me like a path that I can take to really dive into the internals of Maven. And codingcoach.io is actually a free platform where I personally am a Java coach, so I get invites from people all over the world to help them learn Java. That can be really basic things like, I learned classes for the first time, but it's not clicking. Can you explain it in a different way? A coach can really help you, and there's absolutely no shame in getting one. And if you have time, I really recommend that you sign up yourself, because there's only 2 Java coaches. I'm the Belgian one, and the person who gave the keynote, Michel, was actually, I think, one of the only Dutch Java coaches on this platform. But then, then you kind of know what you want to learn or where you can focus, or at least where you can eliminate some of the things. Like you have this massive wall of information, but using those strategies I just showed you, you can kind of limit what you can and want to study. But then you have to apply what you learn. And why do you need to apply what you learn? Well, that's actually part of the next thing I took from my education degree. This is Bloom's taxonomy, and that's actually how a lot of teachers build their lessons. So at first, you have exercises that you basically remember the content. So that's plainly reading like French words and repeating them so they're stuck in your head. But if you learn separate French words, you can't really do a lot with them. Words only make real sense if they're in the context of a sentence or even a paragraph. So first you need to be able to remember things. Then you need to understand what they mean. So remembering is, oh, I know this word, but I don't remember what it means. It's kind of weird. But then, if you actually think about what our job is, I'm going to skip one. If you think about what our job as IT people is, well, we create. We have to build stuff. We have to evaluate. Hey, is this framework? It's really annoying that my pointer isn't working, by the way. We need to evaluate. We need to make critical decisions. Is this framework what we want to use? Is this database the thing we want to use? And we have to analyze. We have to examine. Now, before you can do those top things, you need to be able to apply your knowledge. So you need to be able to write a database query if you want to have any concept, if this is a good idea to use this kind of database. So applying really is a big part of what studying is. I believe it's Angie Jones who also said that if you don't apply what you learn, then you will quite easily just forget it. And also, it's a bit more, maybe that's just me, I'm a very practical person. I like to just tinker and play with the things that I learn, but it really helps me to run into certain issues. And that's also what I want to dive a bit deeper into. So the talk was called Learning Through Tinkering. So that begs the question, what is tinkering? So tinkering really is experimenting with ideas in an integrated environment to fully understand their capabilities. So it's really when you have learned something, so like today you've learned a lot of different things, really take those things that you learn and try to apply them in an environment. Now, I know that's kind of vague, so I have a few examples of my own to show you, and I will explain kind of how I approach my learning in these cases. So the first project I used was, well, the first idea that I have is to really limit myself. And that comes back to those circles I showed you before. It's really reducing the cognitive load I have when I try to learn something. And the thing I really wanted to learn at some point, because I'm a giant nerd, is I wanted to make a game. Does anyone know which game this is? Yeah, Portal. So this is Shell, she's called, and then there's a cube that may or not be sentient and alive inside, but it doesn't really matter. So I wanted to build a really simple game. So, okay, I said to myself, but what do I want to get out of it? Well, I mainly, as a learning objective, want to learn how to make the game engine. Now, you could say, yeah, there's plenty of game engines out there, just use one of those. But that's extra cognitive load, because then I have to learn those engines. So what do I already know? What am I going to limit myself to? Is I know Java. So I'm just going to try to write it in Java myself. So then you need two things. You need a game framework. So even in the limit myself to Java, I tried to decompose the problem a bit, and I saw two big problems. One, you need a game framework. So that's basically a loop that prints something on the screen. And the second part, because it's Portal, is you need physics. You need gravity. You need wind that blows the cube away or whatever. So the first thing I actually found, let me just switch this to, what is this? All right, let me just switch this to duplicate, is actually an amazing blog where they explain piece by piece how to make your own game engine in Java. And for me, this was pretty easy to read because I have some Java experience. So my cognitive load is relatively low because it's just a few interfaces with some methods, and then I just need to find a way to implement them. So that was actually the first piece. The second piece, and this is the amazing part, has anyone heard of the nature of code? Raise of hands, please, because I hear a few people say yeah, and it's a bit confusing who it is. Okay. So the nature of code is actually a description on how to code physics how to code physics in a way that it's still readable. Because when I started with physics, it was like, oh, I have an x, and then I sum the x's, and then it jumps. And I was messing around with just x and y, and it became a very confusing piece of code. But actually, this book, and it's free online with JavaScript examples, explains in detail how physics works. Let me just see if I can quickly find a code example. Oh, here it is. So this is a ball that has it has gravity, so you can see that gravity constantly pulls it down, and there is a wind force that's being applied on it. So you can see it actually looks very natural, surprisingly, with very few code. So how did they do that? And I will just show you my code. This is the wrong one. These three are the key. So every object in the game world has three properties. It has a location. So I now have a location. I'm in a place. Now I'm in another location. So that's what that variable is. It's a vector. So it's basically an x and a y, as you can see in the constructor, by the way. The second part is the velocity. So I now have a relatively constant velocity while I am moving around. It's not going to be perfect because I'm not that good at controlling my physical movements. And then you have acceleration. So this is going to look very weird, but it's probably the only way to do it. I can have a rapid acceleration and then rapid deceleration. And actually, by combining these three, you can make decent-looking physics. And what actually happens when you update? Your velocity, so that's your speed, gets affected by the acceleration, and then your location gets affected by your velocity. And actually, the location is what you see on the screen. So these affect each other, and it's constantly in a loop. So if I have a high, my acceleration always goes back to 0, by the way. But my speed will be carrying on. So now, how can objects change acceleration, velocity, or location? Well, you apply a force on them. And the force you apply, you add to the acceleration. And that's what happens here. So you can see the cube. Well, I should probably just show you the result first. Oop. So that's the cube. I have a space, and it falls to the floor. How does it do that? Well, this code you can kind of ignore. That's just to reset the cube back to the top of the screen. I have a nice collides method. When it collides with the floor, set the velocity to 0. It just stops. I don't have like a splat physics yet. But otherwise, we apply a force, and that's the gravity force. And what is gravity? It's a vector. So everything in this game is based on vectors. Now, the cool thing is, to make more complex physics, I add more vectors. So let's add some wind. And a vector has two ways that it moves. So for gravity, it pulls you down. So that's an increase in the y-axis. For wind, well, wind doesn't necessarily pull you down, per se. So let's just change this up. And then we are going to apply it just always, even when it's on the floor. So cube.apply force, and that's the wind. So you can see the code is actually amazingly readable. So let's just relaunch this one. So it works. It works, it didn't lie. So if you would implement it naively, so being with the x and y and just manipulating the x and y location manually, now you would have a very messy code where the x and y would have to search. But when you look at the code now, what do I have to change to reduce the wind power? Yeah, lower to 0.5. So let's just add. It was really fast to wind, so let's just put it way lower. See, it was better. Oop. And you can see that the physics actually look pretty good. Now, why did I show you this? Well, this is some pretty complex stuff. I learned a lot about physics. I learned a lot about how to design my classes in a good way. I learned a lot about Java. And the only way I was able to do the physics implementation, according to what I truly believe, is that I did it in Java. If I had the cognitive overload of having to do all of this in a programming language that I didn't know, then that wouldn't have worked. I would have been constantly searching the smallest details of the programming language. And that's what I see happen a lot with some colleagues or friends that try to learn something new. They think, I went to a conference, I learned something about Hazelcast, which is a way to store data. I learned something about Quarkus, which is a framework I've never used. Oh, but I'm going to do it in Kotlin, which is a language I've never used. Let's make a hobby project that does all three together. And the result is you're constantly Googling and you're having an awful time. So really, when you want to take something that you learned today and you want to apply it, then really limit yourself. It's okay to choose just one thing and all the rest can be something you know already. How this also applies is when you onboard a new member. So we have a really complex project, a new team member in our project. Sorry, I should have made that a bit clearer. We had a new member joining our team. We have a very complex project with a really difficult domain to get and a lot of different frameworks. We have Spring Batch, we have Quartz, we have just a whole bunch. And I could have just said, okay, here's a task, go. But that wouldn't have worked. So what we did instead was we gave him an exercise that has nothing to do with our domain. We gave him an exercise that first showed him a bit of Spring Boot, then we added Spring Batch, and then we gently injected new things that are relevant for the project, and then we added the domain on top of it. Because when he was looking at the code the first hour or two, he was just lost. Because even if he knew those frameworks, the code would have been hard to understand just purely by the domain. So take this along as well when you onboard a new member. Really try to limit the cognitive load that you put on these people. The next thing you should really do is reflect. How many of you have a project that is on the GitHub graveyard, as I like to call it? You started a project, a pet project, and yeah, it just ended there and nobody. A raise of hands, please. Well, almost everyone, of course. Did you ever think back on why you quit? Did you reflect on why you stopped? Because there's actually a lot of valuable lessons in that. Did you quit because you didn't like it? Because if you didn't like it, then maybe that should be taken into account when you're looking for a career. Like, I'm deadly serious. I tried some machine learning and I really didn't like it, so if someone asked me, Tom, do you want to do a machine learning project? No. I tried it in a simple way. Now, I had to learn this one the hard way, and this is not a nice story, so be warned. I had the immense privilege to be a teacher at a Java minor, so that's basically me in front of a classroom, 4 months, down, putting all my Java knowledge on developers. So and it was only Java, by the way, so there's a lot to say about Java in 4 months. So I had that privilege, but I had an attendance list. So every day the students came in, I had to mark them like, who's here, whatever. So I thought, I'm going to automate this. I'm going to put a camera, point them at my students when they come in, and then I can automatically register it. People look at me strange, like, why would you do that? This was before GDPR, and I had them sign like papers that it was okay, so relax. So I said I don't really like machine learning, so I found the Microsoft Cognitive Services Face API. This is basically a REST API where you send pictures to, and it will send you back who it recognized. A REST API I can do. But there was a problem, because you have a camera, which is a stream of images, and the API, which just takes one image at a time. Now, you could just take the camera and take frames and send each frame, but the cloud is still expensive. We don't always want to admit it, but those services are expensive. So I put something in between to check if there's a person on the frame, and only then I send it to cognitive services. So I used OpenCV. Who of you is familiar with OpenCV? Quite a few. Well, OpenCV is, to put it blunt, an image processing framework that allows you to work with images, read the camera, and so on. So I think I can do a quick demo of this. Let me just... It's really simple, because what's really awesome, and you don't have to read all the code, I'll put it online later and then you can check it out yourself, but this actually comes with a pre-built model to detect a face with eyes. So let me just, it's kind of dark here, but you can see, nice and creepy. So that works. So I draw the green rectangle only when it detects a face. So when you use that, I basically loop over the camera, and when it detects a face, I use this little line to send it to the cognitive services. Cool, worked great. Until one of my students came to me and said, hey, Tom, it's not working. Now, I'm the kind of teacher who kind of gets excited when I screw up, because that's a nice teaching moment. So I took the class with me, and we just looked through the code. We really couldn't find the issue. And I was really getting annoyed, so I took, instead of taking the camera stream, I took this picture and I put it through the algorithm, well, the code. And yeah, that was pretty embarrassing. So I think you can guess, this is horrible. And I really reflected, as I said, you should reflect on your mistakes, but also on the projects you do. I really reflected on this a long time, and the parts where I went wrong is, well, first, don't trust a machine learning model that you got for free online, because clearly there's biases, and you don't want to accidentally build racist software. And I think the most important lesson was, maybe don't automate things that only take 2 minutes to do anyway. So really reflect on what you do. And this goes for a project you do, because we have retrospectives, but does any of you ever reflect back on when you do like one of these pet projects or just little projects to learn? I think we just let them die on a graveyard. And that's kind of a shame. So if you go home and you open your GitHub the next time and you see one of those projects that's like 2 pages away from your repo list, then maybe have a look at it and think back, like, why did I ever stop this? Or why did I even start this? The next thing you should really do is be really conscious about your learning goals. So whenever you start something, really think, what do I want to get out of this thing? Let me show you an example where I really didn't do that well. Does anyone know what this is? Well, I get a nice drink. Please feel free to yell out. The Large Hadron Collider. Do you know what it does? Kinda, yeah. Can you try?
Well, it speeds up like protons and stuff to like 99.9999% of the speed of light and collides them to see what kind of decay particles.
Okay. I'll repeat because this is being recorded, so I'll repeat your answer quickly. So it's kind of awesome. So when you want to learn more about the universe, and you have these small little protons, which are like one of the smallest things in our universe, if you want to make them smaller, you have to ask your government to build a giant circle of 30 kilometers that accelerates these protons, smacks them together, and then they fall apart, hopefully. So that's kind of amazing. So I couldn't do this for my project. I usually say as a joke, I'm from Antwerp. We're really bad at building huge rings around our city. If you've ever visited, you know what I mean. But this is actually part of reverse engineering. So if you want to, it's not a bad idea to try to recreate something. A lot of people say, oh, I don't want to try to recreate Twitter because it's boring. But when you think about it, just try it out for once. See how well it will scale. See what frameworks you need, what kind of monitoring you need. You can still learn a lot by trying to build something that already exists. What I wanted to build, it was 2016 when I did this. I actually wanted not to build a fake front end for Pokemon Go. I wanted to build the back end of Pokemon Go because I'm a Java developer, and Pokemon Go, by chance, is written in Java. So you start to investigate. And what do you learn? This is one of the API calls. Well, what do you see here? It's garbage. You think it's garbage, but it's only garbage because you don't understand what the garbage is. One man's treasure is another man's garbage, I think. No. So one of the first things I discovered, well, for one, it doesn't use a nice REST API. It uses an RPC, so remote protocol, remote procedure call. It's late in the day. My brain sometimes doesn't cooperate as much anymore. So it only uses one endpoint for the entire application. So that's kind of weird, because I'm used to a REST environment where we have these nicely separated REST endpoints. And the second part is, well, no JSON, not even XML. Well, what is this gibberish? And apparently, it's protocol buffers. This was 5 years ago by now. Does anyone know who is not aware what protocol buffers are, by the way? Quite a few. Yeah, okay, no, that's well, protocol buffers are actually a way to serialize your data, kind of like JSON is, but in a binary format and way more efficient. Actually, I have some data on it. If you look at how long it takes to do the communication Java to Java between protocol buffers and JSON, it's actually quite a significant difference. So if you have a high performance application, maybe you should look into protocol buffers. I've at the end of the talk, I will list a page where I have like a ton of information about this stuff. I won't go into it too deep now. But actually, because I investigated Pokemon Go, I discovered this protocol buffer nonsense. And I've actually been using it in some projects with actually quite some success. So that's kind of cool. I didn't really expect to learn something new, but I discovered something new just by trying to rebuild an existing thing. The second thing that I discovered with Pokemon Go is actually they don't use latitude, longitude to say a location. So normally we're quite used to having a latitude, longitude, like 2 numbers, but Pokemon Go decided to have this totally different geometry structure. Now, I don't have time to go into the details today, and I've not used this, but it's really interesting to see how different companies solve different problems, and that's, I think, part of why you're here today. Now, why did this fail? For me, because, does anyone remember my original goal even? Yeah, Pokemon Go, you don't go any further. I said initially that my goal was to recreate the backend. Was I conscious about my learning goal? No, because I went into the rabbit hole. And that's something you need to be really careful about. When you set a goal for yourself, I want to learn a certain thing, be careful that you stay on that path. And if you find something that you think is more interesting, then at least be conscious about it. Because I just went down the rabbit hole and it was 4 a.m. in the morning when I stopped actually reading these things. Be careful about this one, because you might drift in a way that's actually not relevant for your goals on the longer term. Yes, you learn new stuff. You put it on a list, you put it on the things that you want to learn about consciously. But be careful when you just drift off and you see so many new things, because it can be so overwhelming. I just have a quick look at the time. I still have some time, that's great. Now, when you really dislike something, because and for me that's machine learning. I don't dislike it per se, but let's say I had a quite negative experience with it, as I've shown you a few slides ago. So maybe it is a good idea to find alternative approaches to learn the same thing. So if you want to learn machine learning, maybe find another way that makes it a bit more interesting for you. Try to hack your brain to learn something completely different. For a really simple way to do this is, if you read a book and you really about a topic and you really don't like the book, try a conference talk anyway. See if the different kind of structure in which the information is presented clicks for you. The reverse is true. If today you were sitting in most of the sessions like, yeah, this is kind of nonsense, or this doesn't make sense to me, then still read a book about it. Watch some slides. Because if you look at the same information in a different package, maybe it clicks for you like, oh, but this is really interesting. And the way I had this for me with machine learning, and I kind of like machine learning now again, is I built a small game. Again, yeah, it's just what I love doing. So does anyone know what the little figure is? Yeah, it's a Totoro. So this is, you have the Disney movie universe, and then you have the Studio Ghibli universe, which is more, I think, Japanese-style cartoon movies. And this is a figure. So what did I build? That's this one. Let me just boot it up. Yeah. So this was supposed to be, and that's already a kind of a spoiler, this was supposed to be a kind of Flappy Bird. Does anyone remember Flappy Bird? Like you tap your screen and it jumps like this. And then bars come from the right of the screen. I didn't implement those here, but you can see I used a bit of the lessons that I learned with the Portal game, like the gravity and so on. That's actually in this as well. But yeah, I was looking at this and I was thinking, how can I make this fun for kids? And how can I make this really interesting? And then, yeah, I told you I'm a huge nerd, so here he is. So I was thinking, how can I use this as a controller for that game? And unfortunately, I had to run into my old arch nemesis again, machine learning, because yeah, it needs to kind of find a way that if I move this in front of the camera, that it kind of recognizes, like, how would I use this? So purely, yeah, it's quite a difficult task. And that's when I was looking like, okay, I want to make this happen. It's going to be fun. It's going to be cute to show to, like, little nephews or something. And then I actually discovered an amazing tool. Let me just close this. The Teachable Machine. Does anyone know the Teachable Machine? Not a lot of people. So this is a machine learning project that actually helps you to easily train machine learning models. So the really difficult part of machine learning is usually training a model, but this can just work. So you have to say the things that you want to recognize. So for letting him fly, so letting him do the jumps, I thought, well, what if he flaps his arms like a sort of penguin like? So now we need to recognize these, and you can actually use a webcam to record examples. Okay, and I need to kind of stop this because I did it wrong, because that wasn't open. I just open and closed. So this one is going to be the one with the arms open, and I hope it works because it's pretty dark in here. Come on, record. So you see, arms are open. You flip it about a bit. Okay, that was the first, and then the closed one. And then they always say that machine learning takes a long time, but actually with this, it doesn't. So what this tool does, that's something I learned afterwards, it takes an existing model, and instead of training it from zero, it prefixes the existing model and appends a few layers after it. So you're actually taking the output of one existing model and you're putting it into a new model that you train. So, does he work? Ha! Oop. 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 So you can actually upload this model to the cloud, and it actually, it's not that difficult if it just spits out the JavaScript code that you can use to make this work. So let me just quickly get back to this one. And I uncommented one piece so it didn't trigger. So let me see if he wants to cooperate with me today, because this is always like, okay. I just take my F12. The errors are kind of normal. Oh, no. Come on. No. Not today. Think it's too dark. Shame. I have a video of this on my website. Oh, come on. Is it me? No, I have a video of this on my website. Of course, I only train it with like 6 seconds, so you can train it with more examples, and then it actually does work a bit better. So, try an alternative approach, and maybe you will find love for the thing that you actually hate. So I hated machine learning, but because of this, come on, it's too cute. Come on. So, why would you ever apply what you learn? Well, it improves your retention and recall because you're actually training your brain to recognize certain situations, and it will really help you get back that information from your long-term memory. You will discover unknown unknowns. I think everyone has this when you try a new framework and you run into an error message that is nowhere in the documentation, but then you find a Stack Overflow page that lists exactly that. Those are like unknown unknowns or quirks that the framework has. And maybe you find an easier way to do stuff. Like with the teachable machine, it's a pretty easy way to do machine learning. And if you find an easy way to do something, and then maybe that inspires you to learn more about how the more complex stuff actually works. So I've gone way too slow. So I'm going to skip this and go right to getting the most out of your knowledge. And I only have one slide that I really want to show you. It's been proven time and time again that when you are sharing what you have learned by blogging, by making videos, that actually helps you a lot more than you're helping other people. Because if you write a blog about something, then you have to do research. You have to learn more about how something works. That helps you to remember it better, and it also helps you, also helps other people. And it's actually quite funny when you write a blog about something, you forget that you write the blog, And 2 years later, you Google an issue and your own blog is like the first result. That's a really freaky feeling because you know it was somewhere in your head, you forgot it, and as soon as you see your own post, you remember it again. So share what you learn, you'll get a lot out of it. So I've tried to explain to you a few things about your toolbox, that you should constantly be iterating and learning more and improving. But in the end, who's actually responsible for improving it? Yeah, that's you. I have a lot of discussions on, should this be company time? Should this be private time? Well, I don't know each of your individual situations. I don't know how your boss looks into this, but really advocate for yourself that you get some time to actually apply what you learned today. Because you learned a lot of things today, and it would be a waste if you let it go to waste. If you just don't do anything with it anymore, you will not remember as much as you could have. So I've shown this model, but the most important one is this. Remember this simple model of a few circles. What you know, what you can learn, and what you can't learn. Because if you have too much of the middle, it's a bore out, because you're constantly doing what you already know. The sweet spot is getting enough new things that you're triggered to learn more, and that makes you a happy person to just always push the boundary a little bit. And be careful for the outer one, because if you constantly get new stuff that you don't understand, you won't feel as well, and that could lead to a burnout. So I've shown you a few things. So my call to action in the end of this talk, so we can all go to get a drink, is if you do one thing, let's really choose any topic that you've seen today. It could be Quarkus, Kubernetes, Kotlin, doesn't really matter. Really try to do something with it in the coming day, preferably tomorrow or this weekend, and really share what you have learned. Write a blog. Show your friends even. It doesn't have to be like formal in some written knowledge or whatever, because it will really help you at least retain something. You've spent an entire day sitting here. Don't let it just be sitting in like an audience. Let it be something that you take along for the rest of your career by embedding it in your memory. Because if hours and hours of sitting here doesn't really pay off, then yeah, I'm sorry, but then why were you here? That was my talk.